So Bill and I both are in Colorado, as you can tell. I'm up in Estes Park, Colorado, which is basically neighbors to Rocky Mountain National Park. And this is just my second year with Globe, so I haven't really done a long-term project with the kids. And teaching sixth grade, I wanted something that was very hands-on, where the kids could actually see what was happening versus just, using remote information that was being downloaded onto a computer and analyzed to try to look for patterns. So that's why I chose trying to do a project with phenology.
And I've been in Globe for many years, and this is my first year with phenology. I'm also doing macroinvertebrate sampling in our stream. We did it in the fall, and we'll do it again in the spring to see if there's any difference in indicator species of invertebrates.
Okay. So this is a repeat of what we had done back in June to try to keep ourselves on track as to what we're doing. And again, trying to tie it into the Student Climate Research Campaign was to look at, well, what do scientists use to help monitor any climate patterns, changes, et cetera. And so since Bill and I have, weirdly enough, very, very similar latitude, longitude, which you'll see later, our climates are extremely different as well. And so there's just a bullet list of what the kids we're going to be focusing on for the project.
Yep, that's everything to add.
Do you want to talk about the map?
Yeah, sure. Lafayette, where I'm located, is called the Front Range of Colorado, and it's actually the beginning of the Great Plains. We're at about 5,000 feet elevation, so it's pretty high, but relatively flat. And then just heading up the mountains, we'll run right into Estes Park, and so we have a really interesting comparison in our similar latitudes with difference in elevation of, I guess, what, 3,500 feet from
Yeah, our
Lafayette
elevation is
to Estes?
7,500. So
Oh,
yeah.
7,500? Okay,
Yeah.
so 2,500 foot difference.
Okay, so putting it into context with our project, we did some research earlier, again, back in the June cohort, as to how do scientists that are studying climate utilize phenology data, information, et cetera. And so having just kind of scanned the Globe website initially, you get some really awesome modeling images that you can show, which is, again, very good for middle school because they're very concrete level learners, especially at sixth grade, so when they can see the color change, see the patterns, look at the seasonality of it, it seemed to be a good fit, but also very basic in the sense of getting the science across. And so we were doing both the green up and the green down. So we'll talk about green down later, and we just both started green up. We'll be starting green up in the near future. So that'll kind of be a work in progress.
Right, and we were hoping that these would be ways to show kids what scientists would do to study indicator species, and over a long period of time, it could show changes for climate.
And this is just trying to put it into context for the kids very simply, our students. How does climate change fit into the curriculum that they're learning, but yet also would be utilize the data they're collecting by scientists. So again, just going with the seasonal changes, and again, it's long term. So that whole, understanding of weather versus climate is extremely important for kids to get that point across. I don't know how many years I'll be teaching, but you need at least 30 years of data to consider it climatic data. So it's a long time, and in kids' lifespan, it's hard for them to sometimes get that perspective, but we're making, a contribution towards that collection of climatic data. Yeah, I guess I'll start with my tree species that we had used. It's the quaking aspen. First, let me back up. There's not a lot of deciduous trees in the Estes Park area. The primary type of trees that we see are the coniferous trees, everything from like the ponderosas to blue spruces to Doug firs. And it was really interesting for me because I see, aspens here and there, and then when you have to come down to taking a class of kids out and finding accessible trees within the class period that aren't being having their habitat, affected or altered. We had one patch of aspens, which I remember back in June, like, oh, that's great. The trees are right there outside the front of the building, but then I found out they're irrigated, and then we got some elk that can forage, so the kids couldn't get easy access to the trees. And but I thought, that's kind of the typical tree that you see up in this area anyhow. And so we went ahead and studied the quaking aspen. So that's what we did.
Yeah, and we chose cottonwood. That's a real common tree along stream banks in Front Range of Colorado and all the way out, through Kansas, I think. We have aspen also where we are, but they're not native. So we went with the cottonwoods. Ran into a lot of the same problems. We found cottonwoods near this classroom that weren't irrigated, but they are along the side of an irrigation ditch. But of course, that's where they normally would be found anyway. They like that stream bank. The problem that we have with cottonwoods is that they get so tall that it's very hard for kids to reach the branches. So we found a few smaller ones that they can access.
And just to kind of share for people that aren't from Colorado, I did a little bit of research. It would have been great if Bill and I could have both had the same type of tree species for obvious reasons, the difference. But the aspen are much more hardy. They can go down to minus 70 Fahrenheit, and again, this is USDA, so nothing's in metric system. So minus 70 is the lowest temperature range for the aspen. The cottonwood only can go down to like minus 13 is what I had found out. And cottonwood can take 165 days minimum is what they need for frost-free days, and the aspen only needs 70 frost-free days minimum. So there's a big difference in the hardiness of the two trees. Again, as Bill mentioned, cottonwood need a lot more water. I think it said 20. There was no unit. I'm assuming that's inches per year. And then the aspen only needed 7 inches of rain minimum per year. You see my son here. He's here. He's my buddy. We're talking to people.
Mama,
I know, just a minute, hon.
sugar not down.
Hang on.
That's
Okay.
fine. The other interesting thing about cottonwoods that makes it good for us is that they've adapted to life on the Front Range where we very often get heavy, wet snowfalls. And so their green up doesn't happen as early as a lot of the other trees. So we just started our green up today, and we had a few bud bursts and a few swelling, but no leaves out yet. So that's good as far as us, as our school schedule, trying to do the green up.
Okay, I'll just kind of skip through this one, just kind of, again, putting what we've done locally into a bigger context for the scientific investigations. And so here's our trees. Again, it's kind of this little plot of land between the parking lot that you can see there and our school's just behind me when I took the picture with the kids. And so this is back in October, the picture on the left, and then this picture on the right is when we started green up the week of March 26th. So you can even still see that some of the leaves kind of were able to be maintained over the winter, and not the branch or the tree that we had studied, but they sometimes can hang onto the leaves throughout the winter season. And then with our green down, the kids had the Muck Plant Color Guide, and that stands for the Modified UNESCO Classification. So that's basically an international standardized color code for vegetation coverage. And so I'll just kind of show it here. It's just one of these little deals. And it's great because, again, it's very hands-on for the kids, and they have to discuss, well, no, it's this color code, or it's that one, especially if the leaf's not directly easily identified. And then with green up, as I said, we started end of March, and we had a bunch of snow again yesterday. It's already melted off, so they just tagged the branches, and the kids are good now at being able to identify the terminal bud and then work their way back up and keep track of the bud burst. So where we are with green up is within even a week and a half that the buds are starting to swell. They're still majority dormant, but the terminal buds are starting to swell up.
And this is our study site, which you can see from the speed limit sign is right along the side of the road. And there's a little irrigation pond behind that. And at our school, we just introduced iPads this year, and I've been trying to find ways to integrate them. We used them in this project for taking pictures. There's a compass app that we could use to find the compass directions to take our 4 study site pictures. And then since this was our first year doing this project, we didn't have the color key when we started. So we had to kind of problem solve how could we record that. And this was one of the things that the students came up with, writing the number of the leaf and the date, and then taking a picture with their iPad. And then when the color keys came in, we just went back through the pictures. The thing that was really neat about this was that we had the ability to zoom in really closely on these leaves and get a real nice image for determining what the color was.
Okay, and so this is just a tie into the SCRC. Again, with us not having, even though we're like right next to the national park, we wanted to do the land cover protocol, but maybe I'm not familiar with it, but it seemed like you needed to be in some natural habitat, and we pretty much have, you know, a school campus, so there's all three schools, a lot of pavement in that area, but when you look around, you can see the mountains, the park, etc. So anyhow, we did go through the climate classification protocol, and we had to use Denver data because there was no 30-year data for Estes Park specifically, and the kids were able to figure out, well, here's the climate of Denver. We had to, you know, submit that to the Globe website, but we also put in with the metadata piece that, well, our elevation is much different than Denver, which obviously would mean that we have a different climate. And these are just some of the resource lists that we've used. There's other tie-ins to like Project Budburst, et cetera. So quite a lot out there with phenology. And I guess I'll just run through the challenges. Initially, again, the tree species in our class schedules are different between our two schools, and even grade level can be a challenge too. When you got 6th graders and 8th graders, it's night and day, as a lot of middle school teachers know. We do have iPads as well, yeah, but they were piloted by only a handful of teachers, and I haven't had enough time to really get to know them and work with them. But next school year, we'll be able to. In fact, we're actually getting MacBooks for teachers next year. They're replacing our old big, huge desktops. So it'll be mainly integrated with Apple products. The new website I'm excited about. And again, not just having that time to be able to navigate through the Globe website. The current one is a little bit confusing, and not knowing, okay, where's the best way for me to get the data that's on there to apply it to my classroom. Entering data is a little bit of a challenge as well, just to get kids set up and being independent to go down to the computer lab and input the data that we're getting. And as I mentioned about the trees, hard to reach them. And then there's proof of those elk that are foraging. We came out and there's a big pile of scat right by our trees. I thought some kids had vandalized our trees. I'm like, those darn kids. And then you could just tell the trees were bit and, you know, chewed off, and then a bunch of scat. So it's one of the challenges in a natural area.
Yeah, we ran into the same kind of things, and time has been a tough one for me because I'm adding this to a really full curriculum already and trying to figure out what I will substitute, what do I not do in order to find time to do this. And one of the things that's been hard for us is entering the data. So we have it all, and hopefully by the end of the year we'll have it entered.
We're the same. And this is just back to one of our misconceptions we had identified before we started. And again, it's that whole point about, you know, weather versus climate, and also that you just can't go through a single season's data to say that that's climate data. You need that long-term, you know, 3-decade. And just to kind of wrap it up here, so again, just looking at what our you know, situation is with Estes, and kind of knowing the pattern, you know, having lived here about 16 years or so, I can kind of, I had an idea when I went through the Köppen key to figure out climate classification, and it came out to be DFC, which weirdly enough is I found when I was doing some research on Köppen climate classifications, that's the same as Siberia. So we do have very cold, very windy winters. We get most of our snow this time of year. We easily have snow until the end of May. We don't get a lot of snow early part of winter. You know, December, January can be pretty dry here. And we actually do have cactus growing up here in Estes Park, which I was surprised to find when I first moved here. So we are still semi-arid, you know, cold, but, you know, not uncomfortable in the summers.
Well, and the elevation difference is something that I was really interested in because in our earth science class, we talk about how the change in elevation is very similar to a change in longitude. If we were to stay at the same elevation and go north in longitude, we could get to Canada and see the same climate that we'll see when we go up into the mountains, and we can go to Estes and we can go higher from there. So when we do take trips to the mountains, that's one of the things that we like to look at.
Right, yeah, and just one final point. I was hoping that, we would have seen more of a dramatic shift in the green down, but, we're pretty similar. Ours actually started later, which I thought it would have been earlier. But again, it's probably due to the differences in tree species and or possibly the irrigation of our trees. But it's just good that we can compare the data with what we've got anyhow.
Yeah, I would agree.
Any questions? I guess that's it. Come on.
Thank you.
Yes, thanks.